Okay, so welcome, ladies and gentlemen. And, today, I hope you are fine and you are happy as I am. And today, the topic of today it is about the chemical equation. So, about the chemical equation, we are going to see what is a chemical equation and also the examples of chemical equations and why we need to know about chemical equations. So, as an introduction, a chemical equation, it is a chemical change in which substance combine to form a new substance. It means when there is a formation of new substance, it means the chemical reaction takes place. So then in chemical reaction, new substance is formed which is completely different in properties from the original substance. It means there is a difference between the original substance as raw material and also the product formed. So that during a chemical reaction, reagents are transformed into another substance carried product. It means we have raw material, so that raw material is considered as a reagent or reactant, and also the product it is like the substance formed there. So then the reactant are the substance which undergoes chemical reaction. It means we have reactant and we have product. The product is the result or the result formed after chemical reaction to take place. So in a chemical reaction, there is appearance of product and also disappearance of reactant. So here we have an example of chemical reaction. When magnesium burn in air, a white substance is formed. That white substance formed is called magnesium oxide. It means we have reactant, two reactant, to have magnesium and have oxygen. So the oxygen reacts with this magnesium to form magnesium oxide. It means the magnesium oxide it is a product where magnesium and air it is a reactant. So another example we take a charcoal. When you burn charcoal, it forms carbon dioxide gas. So it means here you have a charcoal contain magnesium. I mean contain carbon. Then carbon, if you burn carbon, you form carbon dioxide gas. So from here, carbon it is a reactant, and air or oxygen it is a reactant again, and the product formed it is carbon dioxide. So it means we have many examples of chemical reaction. We have more examples. So what you have to know how those product are formed, what makes to be combined to form a product, what makes it to be transformed into new product compared to original one. So in this lesson today, we are going to see how does it takes place and also another related concept in this lesson. So here we have those examples are word examples, but you have, as we know, the chemical reaction, you understand what we call chemical formulas. So, and the chemical formula, it is a symbol that shows the chemical reaction. For example, if we take water, react with another substance, you have to know the chemical formula of that substance. So, example here, we have potassium iodide react with lead nitrate to form lead iodide and potassium nitrate. What does this mean? This is word equation, but you have to transform into chemical equation or chemical formulas. So we potassium, it is symbolized by letter K, which is a capital, and the iodine is symbolized by letter I. We have potassium, and it is Ki, and react with lead. Lead, it is symbolized by Pb, and the nitrate, this is NO3, and you have to remember lead has two positive. It means it has nitrate has one, means that you have to interchange by using chiasma method where two attach on the nitrate, and for lead there is one because nitrate has one as the radicals. So here we have characteristics of chemical reaction. The majority of case reaction is accompanied by one or more observable signs. It means during a chemical reaction, there is observable features, there is observable characteristics or sign. So sign number one, energy production or absorption. It means the chemical reaction can consume or can need energy to be in order to form the product. Then there is appearance of new substance. It means we have original substance, and this original substance can be transformed into a new substance. It means there is appearance of new substance and also disappearance of original substance. So another characteristics, appearance or change of state of matter. It means the state of matter also changes. There is evolution of gas, evolution of light, evolution of sound. Some reaction not at all, they produce a sound, other they produce a light, and other they produce a gas. So those are the features that show there is a chemical equation that happens. So here we have chemical equation, and it is an abbreviation representation of chemical reaction. It means during a chemical reaction, it is a phenomenon. So the abbreviation or representation of the chemical reaction, it is what you call a chemical equation. So the chemical equation, it is represented using symbols and formulas. So I said above. So let's see how to write and how to read the chemical equation. Before going to this, we have different examples of chemical equation, as I said in above. So the sign positive in a chemical equation, it is read differently as positive, as you know. It is read as react with. It means the sign positive, it is react with, and also in product, it is different in a reactant. In a reactant, we say react with as positive, and in a product, in a reactant, we say positive is read as react with, and also in product positive, we say and or with. Not react, we say and or with. So then another, it is the halo. The halo indicate the direction of reaction. It means reaction is from reactant to the product, because we move from reactant to the product. So that's halo is it means to give or to produce or to form. Those are the different. Those are the same name: to give, to produce, and to form. Those are three names that symbolized by the halo. So here condition if n is written generally above the halo, so it is possible. it is possible to write above the alloy. For example, if the chemical equation involve a catalyst, involve the temperatures, involve any condition, so you have to write the above alloy, even the below the alloy, it is possible. So then here, as the next one, notice that we call the atomic molecule. All molecule made of two atoms chemically bonded together at room temperature and are written with indices 2. What is indices 2? You have to write, for example, for hydrogen, as a hydrogen gas, they have 2 as the indices. It means this hydrogen is the atomic molecule, bromide, chlorine, iodine, oxygen, nitrogen, hydrogen, and so on. So using state of symbol, it means in chemical reaction you have to know the state of symbols. So state symbols, it is better to indicate through the equation the state of matter in which substance are present. It means if the substance is a gas, you have to write a gas. If the substance is a liquid, you have to write a liquid. If and so on. So you have to know the state of matter in which the substance are present. The state symbols used in chemical equation are solid, gas, liquid, and aqueous. It means aqueous is in solution, as you know. So before continue, I hope all of you are able to state the different examples of chemical equation, and also how to write a chemical equation in a good way or in a good manner, which involve the state of matter and also the indices. So in order to draw attention to the fact that either precipitate is formed or gas is involved in a reaction, the arrow pointing down for precipitate and up for gas. It means if you want to show that there is involvement of gas, you have to take arrow move from down to up, and they also for precipitate arrow move from up to down. So rewriting the condition in which reaction takes place, the condition is generally written above or below the alloy in a chemical reaction. Those are the notices as I said above. So you have to remember that if you want to write the condition in which the reaction takes place in present, it means you have to write in the above alloy on the below or on the below alloy. So by writing the symbols of physical state of substance and condition under which reaction takes place, the chemical equation can be made more informative. So it means you have to know the proper way of writing a chemical equation. So let's go on the key point or the importance or the what shows you there is a chemical reaction. So this was explained by Antoine Laurent Lavoisier, was a French chemist born in 1743 and died in 1794. What he did? Heat a red oxide of mercury causing it to decompose or to break down into new product, mercury and oxygen. It means he take red oxide called mercury and then heat it. After heating it, those red oxide of mercury, they broken down or break down or decompose into new substance called mercury and oxygen. So by measuring the weight or the masses of the reactant, before being decomposed, and after they find that the mass are the same. So this is explained using the law of conservation of matter. So after found that the total mass of the product was exactly the same as the mass of metallic oxide, he formulated the laws of conservation of matter. It means the law of conservation of matter consists of two parts. Part one, mass conservation, and the conservation of number of atoms in each element in a reaction. And this law is summarized in: during a chemical reaction, atoms are either destroyed nor created in a chemical reaction. They get transformed. It means the total mass remains constant during a chemical reaction. It means there is no change in mass. In other words, the total mass of reactant is equal to the mass of the product formed. Okay, as I said. For drawing the attention to the law of conservation of matter, of an atom and mass, we have to add in front of the molecules and the atom whole number carried stoichiometric coefficient to get equal number of atoms in both reactant and product. That is balanced chemical equation. So after knowing the mass are the same, so you have to add what you call stoichiometric number. Those are the numbers that you have put in front of molecule or an atom. So they are called the stoichiometric number. So the way of putting that number in front, they call it the balanced chemical equation. If those number are equal, those number represent of an atom or of a molecule is equal to the number of an atom in the product and the reactant. So they are called the balanced chemical equation. So from here, let's say special importance on the chemical equation, the method of balancing chemical equation. Why we need to balance a chemical equation? We need to balance a chemical equation because if we have high mass or high number of atoms or molecule in product and low number in the reactant, it means the balance is not on the same level. So you have to balance those molecules, those atoms, you have to balance in order to make the chemical equation which is balanced. So then from this, it means the chemical equation is approved if it is well balanced. It shows the state of matter and also another related conditions. Then, balancing a chemical equation consists of placing a related coefficient in front of the symbols. Those are called the stoichiometric number, or the formula of each of the substances, so that the equal number of atoms in each element is found on the two sides of the equation. It means you have to show, or you have to formulate the chemical formula which has the same number of atoms in reactant and also in the product. So note that we don't balance. This is you have to remember this one. You don't balance a chemical equation by changing or modifying indices. Make sure that you don't change the indices or you don't modify it. So it means if you modify the indices, also you change the chemical equation. So in balancing chemical equation, the coefficient 1 is not written. it is not necessary to write the 1 as a coefficient, as a stoichiometric number. Don't write 1, it is not necessary. So it means those way of balancing a chemical equation. We have 2 ways of balancing chemical equation. Way number 1, it is what you call random method. Random method, it is like guessing method. It is like to guess, but it is to guess by putting the coefficient on both side and verifying the equal atom. You have to put a certain number on the reactant on the front of an atom, and then you have to go on the also on the product, and then you put the number and then see if there is an equal atom on both sides. It means the equation is already balanced after checking. So to balance the given or any chemical equation, for all the steps. Step 1, write the number of an atom of an element presenting reactant and the product in the table. So you have to trust a table. A table consists of 3 columns. Column number 1, you have to write the name of an atom. For example, if you have, for example, equation iron react with water to form iron oxide and hydrogen. So in name of an atom, we have to write iron, hydrogen as the second on the second, and oxygen on the third. So then you have to write it in the column. In the next column, it is number of an atom presenting a reactant and number of an atom presenting a product. So after doing this, step number 2, balance the atom which is the maximum in a number. So you have to see which atom has a higher number compared to others. So you have to first balance that one on the either side of chemical equation. So you have to see on both chemical equation, even on product on the reactant. So you found the one which has maximum number of an atom. So you have to start from that. So in this equation, as I said above, the number of oxygen atom is in the maximum on right hand side. It means in the product we have higher number of oxygen, so you have to balance that number of oxygen in the product and also equalize in the product. So in the product and the reactant. To balance the oxygen, one need to multiply the oxygen in the right hand side by 4. Because in the product you have 4 oxygen, so you have to multiply on the left hand side by 4. The total number of oxygen atom became equal on both sides. So then after doing this, now the number of hydrogen atom become 8. If you balance 1, it means they make another change to another atom. So you have to continue to see the step by step. So also the number of hydrogen also changed after being changed. So you have also to follow the steps how to multiply. What number can I multiply on the both sides in order to make it to be equivalent? So after that number of oxygen and hydrogen atom became unequal on both sides, the number of iron in one on the right hand side, while it is 3 in the right hand side. It means also iron became 3. It is 3 on product, and also it is 1 on the reactant. So you have to multiply by 3. You have to multiply by 3 on the first one. So then after doing this, now the number of atoms in each element became equal on both sides. Thus, this equation became a balanced equation. So it means after this one, you confirm that the equation is balanced if you check the number of atoms in a product is equal to the number of an atom in the reactant. So you have to check before confirming. So after doing this is the equation which has all characteristics which is required. Equation which is not balanced, it is incomplete equation. The equation will be complete if it is well balanced. So here I provide you different examples of equation. Then you have to complete it. After complete it, you have to balance it. This is by following the above examples, by above procedures. I hope all of you will be fine, and all of you will be try, and you will be okay after balancing this equation. So you provide us a feedback to see if it is well balanced, and also what we are going to correct it and what we are going to improve. So